So still continuing with binomial theorem, we are going to look at this example where it says in the expansion of 2x plus 1 to the n power, the coefficient of the x to the third term is 80. We have to find the value of n. This one is a calculator problem, so make sure you have out your calculators. So this was different from the other ones because one, we do not know what the exponent is of the binomial. All we know is that the coefficient of the x to the third term is 80, okay? So there's a term that is 80 x to the third inside of this binomial expansion. So what we need to do is we need to basically pull out what that term would be. So as before, you know, we need our combination, and then we need our two sets of parentheses to represent the two terms. But whatever term that we get, it has to be the one that's equivalent to the 80x to the third. So what normally goes at the top of the C? And since we don't know what n is, we're going to put n right there. What goes in the first set of parentheses? And what goes in the last? 1. Now, since we do know that this is the coefficient for the x to the third term, automatically we know that this exponent should be what? 3. So far, so good. And then this exponent over here for the 1 needs to technically be the sum of these two should add up to equal n, correct? But since we don't know what n is, what we can do instead is we can say n minus 3. Because think about it. In the formula, it's n minus r, b to the r, right? When you add these two together, you should get n. Well, if I already know that this one is 3, and this one I don't know, still, they need to add up to equal n. So that unknown exponent is n minus 3. That's how we get that, okay? Which means at the bottom here, this is going to be n minus 3. So that's how we set up this equation here. That's how we set up this equation here. Now we need to solve for n. And don't get overwhelmed when you see something like this. We can actually simplify this a little bit. First off, what's 2x raised to the third power?
8x to the third.
Is 8x to the third. And then what's 1 to any power going to be?
It's going to be whatever is first.
It's
going to be itself.
It's actually
It'll be n minus 3.
it's actually going to be actually going to be itself. It's going to be 1. Just think about it. 1 to the 5th power. It's 1. Yeah, you had to mix it up. 1 to the 100th power is 1, no matter what. So this whole expression of 1 to the n minus 3 doesn't matter what n is, because since it's 1 raised to that value, it's going to automatically be 1. So already we got rid of that one. However, this combination is still very much present, okay? And we're going to need to use the formula for combination, which remember is n factorial all over r factorial n minus r factorial. So I'm going to do that in a different color just to make sure that everybody can see this. I'll just make that a little bit smaller. Okay, so this is going to be n factorial all over, what's r in this problem?
N minus 3.
Then I'm going to do n minus r factorial. All I did was take those values and plugged it into the formula. That's how I got n factorial all over n minus 3 factorial, n minus parentheses n minus 3 factorial. All this still equals 80x to the third. I'm gonna show my steps on this, so just make sure everybody doesn't, I don't lose anybody, okay? I wanna simplify this blue part some more. This is still n factorial in the numerator, n minus 3 factorial in the denominator, but this part right here, this n minus parentheses n minus 3, when I distribute over that minus, I'll end up with n minus n plus 3 factorial. And what happens to my n's?
They cancel out.
They cancel out. So then really and truly, I'm just left with n factorial all over n minus 3 factorial times a 3 factorial. This is just the blue part right here. I'll get to the orange in just a second. What do we know is n factorial? What's that formula? That represents n factorial. Yeah, like, well, not formula, but like n factorial is equal to what? Like,
Oh,
expand.
n times n minus 1 and n minus 2 n minus 3 and it keeps going.
What about n minus 3 factorial? What is that? Well, remember we start.
Wouldn't that be like n minus 3, then n minus 4?
And so on and so forth, right? Because you keep subtracting 1. Man, that's what factorial does. It takes it and you continue to subtract 1 all the way till you get to 1 and 0. What's 3 factorial?
3 times 2 times 1.
So this means that the n minus 3, n minus 4, and so on and so forth is going to cancel out with the n minus 3, n minus 4, so on and so forth in the bottom. So what I'm truly left with is n times n minus 1 times n minus 2 all over, what's 3 times 2 times 1? 6. All of this is being multiplied with 8x to the third, and that equals 80x to the third. All I did was bring down the orange part.
Would we have to factor out the rest of the blue or just leave it like that?
That's a personal choice to actually multiply out the n times n minus 1 times n minus 2. That's a personal choice. But it's from this calculator, so we're going to get to a certain point, and then we're going to use our calculator to get our answer. Okay? Now, since this blue part is being multiplied to that 8x to the third, I can actually divide both sides by 8x to the third to make this just a little bit easier. Okay? That's going to cause the 8x to the thirds to cancel out. And then over here, it was 80x to the third divided by 8x to the third. 10.
I'm not getting what you did.
Okay? This blue part right here, this is essentially a number. Remember, it represents a constant.
Hmm.
That's being multiplied to 8x to the third.
Hmm.
So to make this a little simpler, I divided this entire term by an 8x to the third to cancel out the 8x to the third that was already on the left-hand side.
But when, oh, okay, I think I know.
Yeah, so this what I circled in like this tan color, that's a number. So this whole tan color is like saying 3. I have 3 times 8x to the third. So since it's being multiplied, I can divide it out. It won't affect that constant number to continue to simplify and reduce this part over here. Okay?
Thank you.
No problem. So now that I have that, I now have n times n minus 1 times n minus 2 over 6 is equal to 10. And to find the value of n, we're going to use our calculator, okay? We're going to use our calculator to find this answer. Okay? Oh no, I clicked the wrong thing. Here we go. So to do this, get out of this. We are going to go to our graphing feature. We're going to go to the graphing feature of our calculator. So we're going to click y equals. That is our graph, okay? And we've done sequences and series now, so we remember how to put in the fraction feature. Remember how to do the fraction feature on our calculator?
Mm-hmm.
What do I press?
Alpha y equals enter.
Alpha y equals and enter. I'm going to type in the left-hand side into y1. But remember, I can't use n in the calculator. I have to use what? I got to use x. So it's going to be x times x minus 1, close parentheses, times x minus 2, close parentheses, all over 6. Then I'm going to go down to y2, and I'm going to type in the right-hand side into y2. Now, I don't remember the last time you used your calculator and what you did, but since we're kind of like in a new section, I don't want to take I want to put my window back to a standard window so I can see everything. So that's zoom 6. Only because I don't even remember the last time I used my calculator, okay? So the blue represents the left-hand side, and the red represents my right-hand side. The value we're looking for is the intersection between those two curves, just like how it was when we were doing sequences and series. How do I get that intersection?
Second trace.
Second trace. Option 5. Move closer to that intersection point. Remember, because if let's say this was end up being like multiple intersection points. Remember, x represents n. N represents the power for my binomial. We want it to be a positive number. This binomial theorem applies to positive numbers. So once we get close enough, we click enter 3 times. And n is 5. So the value of n in the expansion of 2x plus 1, that will give us the x to the third term to have a coefficient of 80. It's going to be n equals 5. So before we get into this particular problem, we're going to find the coefficient of x to the 5th in the expansion of x plus 3 times 2x minus 1 to the 6th power. I want you guys to consider something real quick, okay? If I had this expression of x squared, x cubed plus x squared minus x minus 3, and I multiplied it by an x plus 3. To multiply this out, wouldn't you distribute x to every term? And then when you multiply 3 to every term? Yeah? So if I'm trying to find one particular term that's raised to an exponent, realize that every variable in this part is going to increase by 1 when I multiply it by an x, right? Because doesn't that turn into x to the 4th plus x to the 3rd minus x squared minus 3x? And then when I multiply everything by 3, wouldn't that turn into 3x to the 3rd plus 3x squared minus 3x minus 9? Okay, so you notice there are 2 terms that have an x to the 3rd that will have to add together. There are 2 terms I will have to add together that have an x squared. There are 2 terms I will have to add together that have an x term. Are you following me here? Whenever you multiply polynomial, an expression, by another binomial, your exponent is going to increase on every term, but there's still going to be another term that would need to be added together that you'll have double of. Take that concept and apply it to this problem. Because when I expand 2x minus 1 to the 6th power, I'm going to have an expression that has 7 terms. It's going to have an x to the 6th, an x to the 5th, an x to the 4th, an x to the 3rd, x to the 2nd, an x, and then a constant, right? Because remember, our exponents decrease. But then every single one of those is going to have to be multiplied by an x and by a 3. So instead of getting the full expansion and multiplying and trying to figure out which ones have the x to the 5th as their variable, you need to try to determine where in that expansion, when I multiply by an x and multiply by a 3, will give me x to the 5th. Now, if you're unable to do this, then you're going to have to spend the time / waste the time to try to expand this binomial and expand it quickly. But again, I'm going to have a term that's an x to the 6th, an x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x, and then a constant. Every single one of these is going to get multiplied by an x when I apply that part here. And every single one of these is going to get multiplied by 3. Which one of these terms is going to give me, and I did them in different colors because remember it's going to be 2 lines. Which one of these is going to give me an x to the 5th when I multiply the expansion by an x?
Would it be the 3rd row?
It's going to be this one. Because when I multiply x to the 4th by an x, doesn't that give me x to the 5th? So this particular term, I need to find the coefficient for x to the 5th. But also, when I multiply 3 to the expansion, wouldn't this also give me an x to the 5th term? So I need both of these terms inside the expansion in order to get the coefficient of the x to the 5th term. So if we're able to recognize which terms or which part of the binomial expansion we need to use, then we'll have what we need. So these are the 2 that I need. I need the one that's going to give me an x to the 5th. So I need the combination that when I do 2x and -1, I need the one that's going to give me an x to the 5th. This one's going to get multiplied by 3, whatever it is. And then I also need this combination, that's going to give me the x to the fourth, that when I multiply it by the x, will give me x to the fifth. Then I'm going to add those two together to get my final answer. So, since n is 6, I can plug those in. If this exponent is 5, what's this exponent over here? A 1, so this is a 1 down here. And if this exponent is a 4, this one has to be a what? 2. So this one down here is going to have to be 2. 6 combination 6. 6 combination 1 is a 6. 2x to the 5th power is a 32x to the 5th. And negative 1 raised to the first power is a negative 1. That is going to get multiplied by 3 once I figure it out. Over here, 6 combination 2 is 15. That's going to get multiplied by 2x to the 4th power, which is a 16x to the 4th. That's going to get multiplied by a negative 1 to the 2nd power, which is a positive 1. All that's going to get multiplied by an x once I figure out what that is. So 6 times 32 times 3, I need to work that out. That's going to give me a negative 576 x to the 5th. That's me multiplying everything in the orange in the first section. That's going to be added to 15 times 16 times 1. It's going to give me a 240 x to the 5th. So then I add those up together, and I'll be able to get the coefficient of x to the 5th and the expansion of x plus 3 times x 2x minus 1 to the 6th power. And that's going to be a negative 336. That'll be the same thing I would get if I actually expanded the full binomial and multiplied it by an x plus 3 afterwards. So again, by doing it this way, I'm only pulling out the terms in the expansion that when it's multiplied by x and multiplied by 3 will give me x to the 5th. If I don't do that, I'm going to have to fully expand 2x minus 1 to the 6th power and then multiply every term by x, multiply every term by 3, and then find that x to the 5th term. That is all of this work that you want to avoid. I got through it in 2 minutes because I'm quick. It might take you guys longer, and I don't want you guys to do that. So try to recognize which terms would give you x to the 5th in the expansion when you multiply each term by x and when you multiply each term by 3. And then only pull out those particular terms and do that with it. Okay, this will be the last one that we look at. This one I pulled from an old IB exam. So go ahead and get this one down. It's going to be similar to the last one. So this problem is similar to the last one. It says in the expansion of ax to the 3rd times 2 plus ax to the 11th power, the coefficient of the term in x to the 5th is 11,880. You have to find the value of a. This one is similar to the last problem because, again, I am multiplying my expansion by something else that's going to produce, that we want to produce the x to the 5th term, okay? But it's a tad bit easier because it's not like it's another binomial being multiplied, it's only a monomial, it's only one term. And to make it even worse, what I definitely don't want you to do is try to expand this whole thing, because now instead of it being to the 6th power, it's to the 11th power. That means that's 12 terms you would have to try to expand out, and I don't want you to do that. That's it's a lot of time, okay? This one is calculator, so it will save you a tad bit of time, but you know, try not to do that. So it's different because I'm looking for A. I already know what the coefficient is of the x to the 5th term. The coefficient is 11,880. I already know what that term is. I'm trying to figure out what the value of A is going to be, so that way I can actually get that particular term. Okay? So real quick, since x is on the B part of the binomial, remember the B exponents increase from 0. So remember, you have a constant, then x squared, then x to the 3rd, and so on and so forth. Okay? Now remember, this is just this part of the expansion. I'm trying to figure out that when I multiply these by ax to the 3rd, I'm trying to see which one is actually going to give me x to the 5th. If you see it, let me know so I can stop. When I multiply each one of these by an ax to the 3rd, which one's going to give me an x to the 5th?
It already happened.
So I'm going to write that one out. It's already happened. Where?
Isn't it the ax to the 3rd and x to the 2nd?
Exactly. When I multiply x to the 3rd times x to the 2nd, that's going to give me x to the 5th. So in the binomial expansion, I want the part of the expansion that's going to give me the x squared in the expansion. So let me set it up. I have my combination. I have my 2 sets of parentheses. What's the value of n? 11. My first parenthesis is going to be a 2. My second parenthesis is going to be the ax. Now remember, the blue represented basically the variable of the expansion for B. I want the one that's going to give me x squared. So that means that this exponent needs to be raised to this parenthesis needs to be raised to the 2nd power, which means this exponent needs to be a 9, which means this needs to be a 2. Now, this is a calculator problem. Can someone tell me what 11 combination 2 is? And just read the numbers left to right.
55.
Oh, really? Okay, I thought it was gonna be longer. What's 2 to the 9th power? 12. And ax to the 2nd power is going to give me a squared x squared. This term represents a term in the expansion that is going to be multiplied by an ax to the 3rd. Because that's what it told me to do up here. That's what it told me to do right there. Multiply the expansion by x to the 3rd. But I only wanted the one term that was going to give me the x to the 5th. Because when I multiply x to the 3rd by x to the 2nd, what do I get? X to the 5th. So I pulled out the right term in green. What's a times a to the 3rd? Gave it away, sorry. A times a to the 2nd is a to the 3rd. And what's 55 times 512?
28,160.
160.
Yeah.
This is to be equivalent to the term, the x to the 5th term, when I actually multiply that full thing out. So I set 160, a to the 3rd, x to the 5th equal to 11,880 x to the 5th. These two should.
Oh, sorry.
Go ahead. So at this point, all we need to do is solve for a. So that means we need to isolate a. We're going to divide both sides by this large number over here and the x to the 5th because I want to get it by itself. So let's do that. Let's figure out what that number is.
Wouldn't it be a fraction? Or a decimal?
It's going to be a fractional or a decimal. So remember, we know how to convert that into a fraction. Let's see, is it a fraction? Yes, it is a fraction, a nice fraction actually. This gives me a to the 3rd is equal to 27 over 64. How do I get a by itself? What do I need to do? I would need
Cube root?
the cube root. And remember, when you cube root numbers, fractions, you cube root the top and you cube root the bottom. So what's the cube root of 27?
3.
And what's the cube root of 64?
4.
So the value of a is 3/4. 3/4 would allow you to, when you multiply ax to the 3rd to that expansion, to give you the x to the 5th term of 11,880. Right? So just make sure that we know how to do cube roots in the calculator and to turn things into a fraction. When we take 11,880 and divide it by 28,106.
All clear.
So to convert this into a fraction, after we do the division, we click math and then option 1. Enter, enter again. That's how we turn it into the fraction. And then to do the cube root, for you, what you're gonna have to do is you go to math, back to math, you go down to option 4. Option 4 will put up the cube root, and then you'll just type in the fraction, 27 over 64. And then that's how we get 0.75. We know 0.75 is 3/4, or we can, again, convert it back to a fraction, math, enter, enter, and we get 3/4. Question?
So if instead of this being a cube root, it was a square root, will we have to do the plus and minus thing?
That is an excellent question. If you have to take the square root or the 4th root or the 6th root, an even root, when you're trying to solve a problem, you do have to remember plus or minus. You will need to use plus or minus. So don't forget about those rules as well when it comes to solving. Excellent question. So this is how you take some of these more advanced binomial theorem problems and to apply it, okay?